Hello everyone. In today's lead code practice video, I won't really be doing lead code practice per se. Rather than give myself a problem that I've already solved before and already have an idea of how to solve it, I'd like to give myself something random, something unexpected, just to better simulate an interview experience. So right now I am on HackerRank, and I'm going to use a mock interview, and I'm going to show myself getting through a 60-minute coding interview just to really show how I handle myself in 60 minutes and just how I'm able to communicate my thought process. This is an hour-long version of the videos I've been doing, where I try to show my ability to handle interviews. Let's do software engineer. Let's try it for free. I now have an interviewer. Hey there, nice to meet you. Interviews can be intimidating. Here's a little bit about me. I'm an AI mock interviewer. You can discuss your problem-solving approach with me, ask me questions when you are stuck. Remember to keep communicating with me. We will start our technical introduction post, which I will provide you with the problem statement, and then we will discuss the problem statements together. Good luck. I'd love to know a bit about your background before we dive in. Could you tell me about your experience with coding and what languages you're most comfortable with? Let's speak. Sure. About my experience with coding, I have been coding for about 4 to 5 years. The languages I'm most comfortable with, Python for sure. That's the one I use the most, but I've also been using JavaScript and TypeScript in open source work. And I believe I'm ready to take a technical interview with either of those languages. Thanks for sharing your background. It's great to hear you have 4 to 5 years of coding experience with Python as your primary language, plus JavaScript and TypeScript from open source work. That's a solid foundation for technical interviews. What kinds of projects have you been working on recently, and do you have any specific areas within programming that you particularly enjoy or find challenging? I have been working on a classroom application, an upcoming classroom application for Free Code Camp. As a way to bring free code camps, nonprofit free online curriculum into a classroom setting that would allow teachers to monitor a classroom of students' progress. I've also been part of San Francisco Civic Tech, and I've been working on a project called Safe Home, which is an earthquake readiness application. And the goal of that one is to help San Francisco residents become more equipped and more aware of how to be ready for an earthquake situation. When it comes to specific areas within programming, I'd say that most of my work has been has been pretty entry level. I'm still working on gaining a lot of experience with different tech stacks, different tools, and there's still a lot that I have to learn. but I always take each opportunity as each position, each challenge as an opportunity for further growth. Okay, let's get into the interview question. The problem statement. Given two strings, string 1 and string 2, where string 1 contains exactly one character more than string 2. Find the indices of the characters in string 1 that can be removed to make string 1 equal to string 2. return the array of indices in increasing order. If it is not possible, return the array -1. We want to use zero-based indexing. Let's say string 1 is abdggda, string 2 is abdggda, and in this situation, because any G character at position 3, 4, or 5 can be deleted to obtain string 2, we want to return 3, 4, and 5. Okay. The input for this situation is a function getRemovableIndices with 2 strings, a string to modify and a target string. The output is an integer array that just lists out the indices of characters that can be removed, or -1 if it is not possible to match string 2. So let's open the code editor. There are a few notes that I'd like to take about this problem, of course, before getting into it. We already went over the input and output and an example, but there's some important context here that I'd like to mention. The first one is that string 1's the length of string 1 is always equal to the length of string 2 plus 1. It's always exactly 1 character longer than string 2. And what this means for my approach is that I don't think there will be a way to remove 2 different characters for string 1 to become string 2. There won't be a way to, let's say string 1 was ABCD, and then string 2 was ABE. It would be impossible to turn, or ABB, it would be impossible to turn string 1 into string 2. The number of characters that are different is more than 1, and we would have to return -1 in this situation. To me, this note about string 1's length versus string 2 is a constraint, and it gives us a clue on what types of strings we can look at and instantly say that string should return a -1. Oh, I see. String 1 and string 2 will also only contain lowercase English letters. So string 1 and string 2 contain anything from A, B, C to Z. So I won't need to worry about numbers. I won't need to worry about spaces, uppercase letters. That narrows down some possible edge cases. All right. So here's how here's a way I want to approach this question. One thing I'm considering is a two-pointer algorithm. And while I'm explaining, let me demonstrate this approach on both string 1 and string 2. Since we want to know what character we can remove at one point in order to make string 1 and string 2 equal, we can assume that at almost every other case, string 1 and string 2 should be equal. So let's say we start with looking at both the A for both strings. We see that both are equal, so we move forward. B, again, both strings are equal, so we move forward. D, same thing. And G, same thing, G, same thing. And now we see that there's a difference here. There is a G, whereas for the second string, there's a D. we now see that there is a D on the first one and an A on the second one, and an A on the first one, and we've hit the end of the string for the second one. And the reason why I'm considering using the two-pointer approach is because it gives us a way to iterate through both strings, which would help us figure out where the differences are. At this point here, where we notice that there's a difference between the two characters, that is when we would focus on this spot and we would say, what can we remove to make this equal? So if we are able to remove this string, this character, I mean, and string 1 becomes string 2, then that tells us that there is a valid solution and we're not going to return -1. And this removal will also apply to any character in the same group that is the same letter. So since in this example we have 3 G's put together, we can remove that any of the 3 G's can be removed in order to make string 1 equal to string 2. But let's say we had a case where this letter was an E. In this case, the only possible way we can remove a letter to make string 1 equal to string 2 is to remove the E. There's only one letter in this group of E's, and so there's only one possible location where we can answer. So here's how my algorithm would look like. First, I want to find the difference. I want to find the difference point, the point where string 1 has a different character than string 2. Secondly, I want to focus on this let's first find the difference points. Let's say I find exactly one difference point, then I want to focus on this and look at the grouping of the same letter. Finally, I want to return all indices that have the same letter as the difference letter in that group. But one thing I'd like to point about step 1, if I find multiple difference points, then I want to return -1. And how will I know that there are multiple difference points? Well, if I just remove the first, if I remove a difference point and then move on to the rest of the string, and I see that there's a different one, then I know that making string 1 become string 2 would require at least 2 removals, and that it won't be possible. So that actually adds an extra step to my algorithm. One, I want to find the difference points. And what would that look like? Well, I would loop through each character until I find a letter mismatch. Then I want to remove the letter from string 1. And then I want to iterate through the rest of string 1 and string 2 until I reach the end. If I find another mismatch, then I instantly return -1. So with that said, I think I can begin coding, but let's go over the time and space complexity. This time complexity should be O of n, as it's going through 1, potentially 2 loops of the string. And in terms of space, it should be constant, as I'm not creating any data structures. I'm only keeping track of using variables and indices and 1 character. Okay, so let's begin coding. First, let's find the difference point. Let's use a variable as the pointer and another variable to keep track of the current mismatch index. Now let's loop through. I suppose this example isn't necessarily 2 pointers, but it's simply using 1 pointer and then running some comparisons. For I in range length of string No, I think a while loop would be more appropriate here. While pointer 1 is less than the length of string 1, I want to loop through each character until I find a mismatch. So if string 1 since I'm using 1 pointer, I can just use pointer. If string 1 is not equal to string 2 at that character, I want to remove the letter. Removing the letter may create an additional string, which I don't want. Perhaps in this case, I would be using 2 pointers. Pointer 1 will be pointing to string 1 and pointer 2 will be pointing to string 2. If the letters are misaligned, instead of removing it, I will simply skip forward that character in string 1. And then, so in this situation, I would just compare D to D instead of looking at this G. I would just skip over it and see if the rest of string 1 lines up with the rest of string 2. Otherwise, if they are equal, I just want to iterate both pointers by 1. And now, here's where I figure out if there's another mismatch, which I'll need to add another function, another comparison in here. If I see that there's a mismatch already, but if pointer 1 is already unequal to pointer 2, then I know that I've already seen a mismatch prior, and I know that there is more than one mismatch in this problem, and I can return -1. Now, one thing I also want to do is keep track of the mismatched letter's position. I suppose this solution may actually be O of n in space if I'm creating an array. So yes, that would make it O of n in space. Let's keep track of the result. And now, after I exit the loop, let's look through the grouping of the same letter. One thing I would like to understand is, can we return the indices in unsorted order? Okay, it has to be in ascending order. I see. So what I would do here is after I find one area where a mismatch occurs, I'd like to check if there are more characters in this letter. So one thing I can always be certain of is that if I see another mismatch, I may need to look into more potential edge cases and figure out a solution that would cover all of my bases. It seems that in the case where there's only one letter extra, the only time I would notice that there's a mismatch would be at the end of that sequence. In this example, we only notice that there's an extra G at the end of this sequence of 3 Gs. And I believe the same would happen no matter which letter we add in an extra of. If there are 2 A's, we would notice at the end of the sequence of A's. 2 B's, we would notice at the end. 2 D's, also at the end. And this goes for every location. And of course, this also goes if there's a character that a new character that's being introduced. M is the only point where string A differs from string B, and it is also the beginning and end of that sequence of M's. So if I can guarantee that the only other mismatched letters that I can return, or the only other indices that I can return, are simply to the left of mismatch, then I want to just keep track of that. Now, I'm sure there's a more clean way to write this, but for now I'm just going to use another variable to keep track of where the first mismatched letter is. I'd like to use another pointer to keep track of this as well. Mismatch beginning keeps track of the index. Pointer is just iterating through different indices. So while pointer is greater than or equal to 0, I want to look at pointer -1. I want to look at the previous character of string 1. And if it's equal to the current character, then I want to I don't think I need another pointer for this. I think I will simply extend mismatch begin, or simply begin. But yes, if I notice that the previous character is the same as the current character, I would just like to increase begin by 1. Otherwise, I'd like to break out of the loop. Now that I'm out, I should have the entire field of characters indices that I can remove. So I'd like to return. Well, I'd like to load up result with all the indices that I can return, that I can remove in ascending order. So in range, mismatch +1, and 1, result should append I, and then I should return the result. Now let's try running the code. Okay, I received an index out of range error. And this happens, okay. So my code, it seems to be able to handle different situations, but there is an edge case where the difference is out of the range of the second string. That's something I need to iron out in this test case before I can really submit this code. And so for now, I'd like to check if, just to iron out that edge case, I'd like to make sure pointer 2 is still within bounds. In this case, I'd like to exit out early. So if pointer 2 is currently at length of string 2, then I'd like to keep track of the mismatch. Pointer 1 or pointer 2, they should be the same in this case. Still equal to pointer 2. In that case, let's set mismatch to pointer 2 and then break from this while loop. Now let's try running our code again. Okay, all available test cases have passed. Now let's try submitting the code. All right, and all available test cases, hidden or public, have been passed. Let's take a look at AI review. I see. The AI also wants us to handle different edge cases. My code was able to handle all of the 15 cases given, but I see. Let's answer each question one at a time. The strings are of unexpected lengths. I see. If there's a case where I assumed going into this problem that the lengths of string 1 and string 2 were a given. However, I think that'd be something pretty safe that I can knock out right at the beginning. If the length of string 1 is not equal to the length of string 2 plus 1, then I want to return -1 right off the bat. Alright, now that the code has been submitted, AI has some questions for me. Yes, I am ready for the questions. Great, let's discuss your solution. Can you explain the time and space complexity of your solution and why? Sure. So the space complexity of my solution is O of n because I need to load the result array in order. Oh, I didn't even start it. So the space complexity of my solution is O of n because I need to return an array of indices, and this this could potentially be the same length as the string itself. So O of n in the worst case. As for time, it should also be O of n because I am doing minimum 1 loop, maximum 2 loops of the string, and I'm looping a linear amount of times equal to the length of the string, and as a result, the time complexity should be O of n. Now the second question I've got is, what happens if in your algorithm if the mismatch is at the very end of the string? How does your code handle this case? Since at most there can only be one mismatch for a valid string, if the mismatch is at the very end of the string, what my code will do is check that the second pointer is equal to the length of the second string, and in that case, it would flag that final character as a mismatch and then break out of that while loop so that it doesn't cause an out of bounds error. It would then treat that extra string in string 1, or that extra character in string 1, as the mismatch that we need to look into. The third question is, in your solution, you're looking for consecutive characters that match the mismatched character. Can you explain why this approach works, and if there are any edge cases where it might not work? In my solution, I'm looking for consecutive characters because due to the constraint that string 1 must be one character longer than string 2, at most there can be one removal that would make string 1 equal to string 2. If we were to remove two characters from string 1 with these constraints, it would be impossible for string 1 to be equal to string 2. Therefore, we can conclude that the character to remove, the possible character to remove, is either the mismatched character or a consecutive character that is equal to the mismatched character. As for edge cases where it might not work, if there are multiple mismatch characters, we would detect that within the first iteration of our loop, and we would return -1 immediately. I see. Fourth question. Your code checks if pointer 1 is not equal to pointer 2 when finding a mismatch. Can you explain why this check is necessary and what scenario it's handling? So the way I'm currently checking if I have seen a mismatch or not, ideally, if I remove one character of pointer 1, the rest of it should be equal to pointer 2. So by the time I see my first mismatch, pointer 1 will be equal to pointer 2. And once I see that mismatch, I would keep track of it, and I would iterate pointer 1 to one index higher. I would then keep track of pointer 1 one index ahead, effectively acting as if that character has been removed. This if statement, this conditional, could also be replaced with if pointer 1 equals pointer 2 plus 1, and it would give functionally the same logic. So if pointer 1 is equal to pointer 2 plus 1 and is no longer equal to pointer 2, and I see another mismatch, that would tell me that I've gotten multiple mismatches. And at that point, I would return -1 as there's no way to make string 1 equal to string 2 with only one removal. The fifth question is, if I were to optimize my solution further, is there anything I would change or improve? Yes, I believe I could cut down on some logic related to creating and loading my return array. I think that right now what I'm doing is pretty straightforward, but I am also directly taking care of a lot of edge cases, and I think that perhaps I could come up with a solution that better handles these edge cases without using too many if statements. Additionally, what we've mentioned in the previous question, I may change line 64 if pointer 1 is not equal to pointer 2 to a different conditional if pointer 1 equals pointer 2 plus 1, so that it's more intuitive for another developer who's looking at my code. I may also add a helper function there. So instead of if pointer 1 equals pointer 2 plus 1, I might say if mismatch found, and then I would create a helper function where mismatch found checks for pointer 1 equals pointer 2 plus 1. I would just focus on making my code easier to understand for another developer. Okay, and that is all the questions I have. I'd like to take a look at my final review. Well, I think that was a pretty straightforward and simple problem. However, I think I stumbled a little bit while writing it. But let's take a look at the feedback. So I have received a 5 out of 5 rating, which sounds great. But let's take a look at what feedback I can use to improve. My code demonstrates good organization and structure with clear variable naming that makes the solution easier to follow. Okay. I think I can skip over reading this and then I'll review it at another time. But I'd say I am finished. Yeah, I think that the interviewer, perhaps there could be a different setting that would allow us to, that would make it so that as soon as the interviewer asks the question, we need to speak. And it would more simulate the situation you'd be in if you were in a real interview. You wouldn't have some extra buffer time to choose when to start speaking That would happen as soon as the interviewer finishes asking their question. Um, let's see. I think I would like, yes, I would also like a more realistic experience. I think I can submit with this. Whew. Well, that has been my mock interview with HackerRank. Of course, I'd like to do more mock interviews. Just just practice these on my own more. Um, but but yeah, I think that was a pretty good experience overall. I'm glad I was able to go through that question and get feedback from HackerRank. But yeah, thank you very much for watching. I'll see you in the next one.